Excellent. Hi, guys. Great to see people pouring in. A nice breadth of names here, and quite a few I know, which is always what I love to see, but also some I don't, which is cool too. I will get started now. If you join, then all you're missing is my introduction, which is probably the least relevant part of all this anyway. So, thank you for joining us this evening. If you don't know me, I'm Kerrin, or KG as I'm colloquially known, and I work for Betfair in Australia. My role is to help people who are interested in automation and modelling on the exchange, and to help to grow and develop this thriving community, and to help make it easier for people who are keen to automate to get access to the resources and tools that they need. So why are we here? Why are we doing this? From a Betfair perspective, hopefully you've heard my spiel before. We're here to create more winners. That's our mission. At the end of the day, we have a different business model. It's in our benefit. If you're successful, that makes us more successful too. So that means, we're here very genuinely trying to help you to expand your winning strategies and your success on the exchange. So I'm going to share some links in the chat at the bottom. So first up, if you're not part of the Betfair Quants Slack community, I seriously recommend that you join. It's started by one of our community members, and it's a really great, vibrant community of like-minded devs and modelers who use the exchange primarily out of Australia. It's like 350 people in there now. Incredibly active and a great place to share your thoughts, experiences, learnings, challenges, and get real feedback from other people who have either been there or are there, but also sometimes to commiserate over some of the challenges. So if you're not there, I suggest getting there. We will have the chat function off in Zoom because we find it's more useful for people to chat in Slack if they want to on the side. So suggest jumping over there. There is a meetups channel, which is probably the most appropriate place to continue the conversation if you're keen. I'm on there and my team are on there as well. So me, Ben and Ash, we're all around. If you want to hit us up, it's a good way to get in contact now and after the evening. More broadly, from a Betfair perspective, if there's anything else that we can help you with more broadly, equally reach out. At the end of the day, that's what we're here for, is to help. So automation@betfair.com.au is probably the best email address to get us on, and thanks Ash for sharing that. And if you're watching this afterwards and you want an invitation to the Slack group, also just shoot us an email and we can share that there as well. So like I said, the chat will be off for the evening, but the Q&A will be on. So if you have any questions through the session that you want to ask, just jump in with them and we'll answer them as we go if it's relevant. Otherwise, we'll come back to that at the end in a Q&A. So what are we here for tonight? We are talking through the FastTrack API, what data is available, and how you might use that to build and implement a model on Greyhounds using the Greyhound form available from the FastTrack API. To that end, we've got a pretty cool tutorial that one of the community's written and a wrapper for the FastTrack API. Now this evening we'll go through the wrapper and the tutorial, and to do that, one of our own has joined in. So Kaushik is going to be walking through this with me, so we can not just have me talking for an hour, but an opportunity to share that. So Kaushik, if we can get you on. Awesome. Thanks for joining tonight, Kaushik. I really appreciate it. Kaushik is our lead data scientist at Betfair. And I've been very, very lucky to have Kaushik as a colleague and a friend for the last few years, and really appreciate you coming on tonight. Kaushik, can you give a little bit more of an introduction to you and your background to give a bit of context as to why you're here as a data scientist, and what insights you can bring?
Yeah, sure. Thanks so much for having me, firstly, KG. It's finally great to be back on this webinar, but on like this side of the fence and not just listen to people. So hopefully you guys have something good to take away from me and the change of voice that that Kerrin said she would promise. So yeah, quick intro about myself. I'm Kaushik and I lead the data science team at Betfair. So we're responsible for a bunch of different things in the predictive analytics space, all the way from sort of customer journey modeling to sports modeling to specific things that are very sort of Betfair specific, like liquidity and pricing and stuff like that. So wide breadth of things, but I'm here mainly to go through the FastTrack tutorial. It's something that we've been using at Betfair for best part of maybe three or 4 years. I don't know how many of you are familiar with this, but we've got a Greyhound ratings model on the hub, which is powered by this among a couple of other data sources. So it's been something that my team and I have been familiar with for a while now. So hopefully that knowledge comes across. And I've either worked with or led people who've built Greyhound models in the past to varying degrees of success. So hopefully I can take away from some of those experiences and share some good insight as well.
Excellent. Right. So in terms of, we keep using FastTrack as the title here, but effectively what we're talking about is the form, the Greyhound form data from the racing bodies, right? So, I guess the first question here is, why are the racing bodies sharing this data and why do we care? So first up, we've got really good relationships across the different racing bodies. And they recognize that by facilitating basically you guys, this community, to have access to this valuable data, it helps enable you to build programmatic models that can then be, basically automated into the exchange. The value in that for the racing bodies is the increased liquidity. And what we see is that when the exchange is doing well, the broader ecosystem is doing well. So by growing Greyhound racing on the exchange, it will help grow it more broadly. And that's what we've got data to back that up across experiences that we've seen historically. So huge vote of thanks to the racing bodies for coming to the table with sharing it and making it accessible. And then I guess, why do we care? Because data is the basis of everything we do, right? If you don't have something to model, well, there's very little stock in being a data scientist or in trying to automate anything. So from that perspective, having a quality, and it really is quality, set of Greyhound form data is basically invaluable. So who's this for? I would say that there are two target audiences tonight. One, people who have existing Greyhound models where you want to improve what you're doing, and you think that these extra features or depth of features would improve your output. Two, people who have automated models on things other than Greyhounds and are looking to diversify, and basically scale out instead of, up. And we've seen some people take this data set and do exactly that, become very successful in Greyhounds where they've got no previous history there. So I will say straight up that this is aimed at devs or people with some dev skills. So, Kaushik, neither you or I would, propose to be like serious devs, but we've both got enough dev skills to pull from an API programmatically and build a model programmatically. Yeah.
Yeah, I've got programming skills, but I'm not a programmer. Is the best way I say it.
Yeah, me too. I call myself a hobbyist. And I think just I don't want to waste anyone's time who's on here for anything more sort of, I guess, manual form related. If so, the FastTrack website is excellent and a really good source for that. But the content of this will be around accessing this programmatically. So, disclaimer, hopefully you know that that's what you're in for. So, Kaushik, jumping over to you. So, talking through, I know you referred to our Greyhound racing ratings model, so we call it EGI affectionately internally. How did we use the FastTrack data in that?
Yeah, so essentially any model, you're trying to build a relationship between a dog's past performance and its ability to win a particular race, right? And the FastTrack API gives you programmatic access to historical data for every race and every dog. So you're able to achieve a certain level of scale and intelligence in your decision making that probably isn't has a limit when you do it visually or when you do it by hand looking at the form. So that's where the FastTrack API comes into play along with all of the other sources that I briefly teased some time back.
So basically, to summarize, the FastTrack API provides two things. One, the historical data, which is what's super valuable here because very few people give you access to that. So it goes back 3 years. And then the second piece is what I consider like the live access. So all upcoming form for upcoming races. Yeah. So sort of two-pronged. And can you speak to what fields are returned? So what do we actually get from the API?
Yeah, sure. So as you said, it's split into two distinct sort of types of data. The historical data, you get as much detail as is captured in all of the Greyhound races. So what was the field of that particular race? What was the finishing time for each of the runners? If sectionals, if they're, if they're tracks that capture that level of data, and most of them do in today's day and age, and that wasn't necessarily the case when we first got access to it. So quite detailed level of runner performance data for all historical races. And for the future, or like the live stuff that you referenced, I think it's basically what you would find on any form web interface, right? Like how a particular dog has run in its last few races, what is its result, win rate, place rate, stuff like that, that you would naturally build into any sort of machine learning framework and feed into a model, but it's just visually available for you. So if you want like a quick access to those kind of stats, that's available as well.
And the beauty of this is it's consistent, right, across the different, that was what absolutely blew me away. Wasn't that they were sharing, I mean, it was they were sharing data, but also beyond sharing the data, that it was in a consistent format. So you can look at Queensland or Vic or WA, and all of them are returning it in the same format too, which makes modeling way easier.
The popular adage is like garbage in, garbage out. So if you're working with good data, then you're more likely to have a good model. And the advantage of having an automated feed like this is it's meant to be structured in a certain way, right? And if you're depending on things like web scraping, like websites can change any day, and then you'll be forced to rewrite things. But an API is not meant to change. It's meant to have documentation, and it's meant to be consistent. So you get all of those advantages as well.
Yeah, which is the beauty of having people come to the table here. So the only thing that's probably a bit of a caveat to highlight is that this API wasn't necessarily built for wider consumption. So bits of it aren't necessarily, at first glance, necessarily user-friendly. And to try and mitigate bits of that's why we've got someone in the community to step up and write a wrapper, right? To try and make it easier to play with the API and then pull that data in, ingest it, and do whatever you will. Do you want to share your screen, Kaushik? Because I know that you've got some things there to go through with us.
Yep, one moment.
Here's one we prepared earlier.
Hopefully people can see that.
Well, awesome. So Ash, can you share those two links in the chat, please? So we've got two things here. So if you want to go to the other one, Kaushik. So this is our Betfair Down Under GitHub repo. And on here, you can see this is the FastTrack folder, I guess, within the AutoHub tutorial section. And in here, you'll find a copy of the tutorial that's also on the Automation Hub, which is what we're about to go through. But you'll also find the Python wrapper itself. So it's in Python because within the community at the moment, for the sort of people who are more likely to find value in a wrapper written by someone else, Python's probably the best one to go with. I'm not a Python native. Kaushik isn't a Python native, but we can both work with it. And that's the beauty of Python, right? Like whether you're a fan or not, it is accessible. So have a look at the wrapper, whether you take that and do your own thing with it, whether it just gives you a guide or whether you just use it completely, that's up to you. But I do think that there is value in this, particularly for people who might be like me and Kaushik, less on the developer end of the dev spectrum. So have a look here, feel free to come and have a play. So if we jump back over to the tutorial, this is what we're going to walk through tonight. Feel free to go and have a look at this, guys. Like we said, it's on the Automation Hub. But essentially, if you run the code that's in here, you can get from woe to go all the data historically pulled down in a format that you can then pull into your model. There's a super simple modeling component to this that we guarantee will not be profitable. And then you can, so part of the process there is obviously marrying up what's coming from FastTrack with the Betfair stuff. Then there's a bit of strategy in terms of what you're betting, and then finding that new data and and deciding what you're going to bet on it. So in essence, this tutorial covers all those steps from the beginning to the end, that whole pipeline, I guess I'd call it, so that you can take this as the foundation of what you're doing. So Kaushik, over to you. Do you want to talk a little bit here about, I guess, pulling that historic data into the database, that sort of first chunk?
Yeah, sure. So I think before we get into all of that, just a quick word on the Python wrapper, right? It's essentially a REST API that returns XML stuff, and the Python wrapper is just converting the XML to rows and columns that machine learning frameworks typically like. So if Python doesn't work for you, all of this stuff is very, very easy to replicate in any language of your choice. So we've actually got like an R package internally that does the same thing. But whatever your tool of choice is, there must be a API accessible package of some sort that you can work with and convert and achieve the same thing. So it's just like KG said, it's Python because that's what the community prefers these days. And it's easy to follow along as well.
Yeah, no, really good description there.
Cool. So yeah, as you can see in the table of contents here, it's divided into 4 sections. So we'll first talk about downloading the historic Greyhound data from FastTrack. How do we go about doing that? And what the data inside that really gives you before we jump on to building the model. So the requirements bit is specified here. There's a bunch of packages that this tutorial depends on. So listed here. Nothing too unfamiliar to people who work with Python and data. So the only difference is if this stuff is new to you, if Betfair Lightweight is new to you, it's just a wrapper again for transacting with the Betfair API through Python. If you're an R person, there's an equivalent A better. If you're a Java person, there's something else I'm sure that's relevant as well. So standard list of packages that this stuff depends on.
I do suggest also updating your version of Python. I know that I had to make sure I was on the most recent version to run it. So
yeah, I think any Python 3 should be fine for this stuff. Cool. So the first bit here is creating a FastTrack object, and that's primarily because over here in this FastTrack.py, it's defined as a class, and once you create an object called Grays here, you can do the rest of the bits that the package provides. So the first thing you'd need is a valid security key. So that's where KG comes into play. You want to give a quick 2-second intro on that?
Yeah, so we'll address this at the end, but essentially anyone who's on our mailing list will receive a newsletter from us, an automation newsletter in the next week, talking about how to get this access. But if you want it beforehand, shoot us an email, data@betfair.com.au or automation, any of the above, and we'll get that ball rolling with you. So that's just talk to us. It's a small community, so we'd prefer to just have that conversation.
Perfect. Cool. So once you've got a valid security key that lets you access this API, you should be able to do everything else below this bit. The one other thing that's sort of in the package or in the code that has been created is a predefined list of tracks with certain details, like a track code, which is very specific to the FastTrack API. There isn't necessarily any sort of documentation on this, so this is kind of manually curated. And again, I think there's a bit of a caveat in terms of what data is available from the API and what's not. KG, you want to give a quick description on that as well, please?
Yeah, so in essence, the data is available for all states and territories except New South Wales. So you can get every other state and New Zealand, just unfortunately not New South Wales. Watch this space.
Excellent.
Which is ironic that we then have New South Wales as the example there.
Absolutely. So there is a predefined mapping, like I said, which is available through this function called list tracks. when you look at the repo, you'll see that there's a mapping.py file that contains a bunch of dictionaries that has a relationship defined between the track name, track code, and where the location of the track is. For the purposes of this tutorial, we'll be building a Greyhound model based on Queensland tracks only. So this bit of code here, make sure that you're working with a filtered list of tracks that's Queensland only. And very smartly, it all starts with 4, I think, which aligns with like the postcode and stuff. That's my 6 years.
The data science.
I was thinking it's more like 6 years of living in Australia and knowledge paying off, but
better than I would get. So you're lapping me again.
Excellent. So once we've spoken about these 2 bits, then we can use the functions that the wrapper contains. So the first one here is something called get race results. So it takes in 3 parameters: start date and end date. And if you want, it can also be restricted to certain tracks. What this does is it returns a couple of objects. So it returns a data frame called race details, which contains details about the race in terms of what the race number was, when the race started, the distance in the race, the class of the race or the grade of the race, and the location and stuff. So the 6th cell here, the output of it is essentially what you would expect to come back when you run this function and get this race details object. The function also returns something called dog results. Same kind of parameters, but it goes in one level deeper and gives you data for each dog in that particular race. So what place it finished at, what box did it run from, what drug did it have, which is the same for greyhounds, the weight of the dog, starting price according to some sort of blended bookie price, and a bunch of other details like the margin that it finished behind the runner, behind the leader, and if it's the leader, it's the same as the margin that it beat the next best runner by. It's got a bunch of other details here. Position in running is this. So the first section it was third, as the second section it was second, then finished first. It's got some details about how many times the dog got checked as well. And it's got, this is the useful stuff, right? So it's got times for the splits. So at the first split, how quickly did it get to that point? And also the final runtime with the race as well. Another thing that's useful typically in like modeling scenarios is the prize money. It's a proxy for, I guess, the quality of the race or the quality of the dog, which can get coded numerically. So there's that available as well. And then if you ever want to work with trainer details like strike rates for trainers and how that affects a particular dog, there's that kind of data available for you here as well. So what this piece of code does here is just fetch that for a specified date range. It can take a little bit of time because the API, as KG said, was not meant to be accessed by a lot of people. So it has some inbuilt restrictions on how often you can query it and stuff. But this particular wrapper has a few wait steps in there to get around that. So don't be alarmed if this takes a little bit of time or if this sort of hangs in the middle. Maybe run it like a few days at a time to see it works and you're comfortable with it, and then you can sort of train the whole API.
I think also just to flag here, super supportive from the racing bodies, and given some of the interest from the community in this stuff, they are actually looking at maybe improving some of the API. Very good timing when we've got this coming out. But I just think it speaks to them seeing the value that this can beget. So as and when we have an update, we'll share it, but we'll also probably get someone to update the repo at that point as well. So watch this space.
Excellent. And finally,
still better than screen scraping.
Oh yeah, absolutely. This last cell here, cell number 8 for reference, is just a little bit of basic data manipulation that we are getting out of these data frames. Just things like making sure that you convert the distance to an integer value and not a character, removing things like meters in there. So your basic data cleaning stuff, if you go through each of these things in step by step, it should be fairly self-explanatory. For instance, let's pick something at random here, right? Like the starting price, it's just removing the term dollar in front of it, making sure that it's numeric in nature. And I do believe there's there's something that starts with F there. So just getting rid of all of that stuff so it becomes useful for you in later steps. Yeah, based on the data and the type of data, you might have your own preferences in terms of how you want to do this, but this is just like a recipe to get started.
This is also some of the beauty of having a wrapper here. Like, again, like we said, whether you want to do it in Python or not, you know, we've had so many discussions about the amount of time we all spend on data cleaning. And if someone can help with the first bit of that data cleaning, like, yeah, it means you spend that much more time on the modeling phase instead of the collection and cleaning bit, right?
Yeah, so that's pretty much the first section where you can play around with the functions that's available in the wrapper, extract data based on certain date ranges, certain track filters, and just do some sort of basic exploration. I believe we've got a Q&A. I saw something pop up.
We do. It's just a question about some of the data that's available for Vic and not for others. Leave that with me. Suggestion, shoot me an email or a Slack message so that I can come back to you personally, because I'll have to go and chase that up and come back to you with a direct answer.
Excellent. Happy to move on to section 2 then?
Yes.
Perfect. So section 2 is building a simple machine learning model. And as KG said at the start of the session, this is absolutely not going to be profitable at all. It's a really sort of dummy's guide to building a model. It has very simplistic features, very big assumptions that won't hold true. So don't create this and expect to win. But use this as a template to think about how you would want to code features into models, and then who knows, you might be onto something. Cool. So there is a bunch of code here that does some very basic feature exploration or feature construction here, right? So feature, for those of you who may not be very familiar with like the machine learning terminology, is things that you feed into a model that are representative of the thing that you're trying to predict. So in our case, we're trying to predict whether a dog wins a race or not. And what you want to do is build in metrics or build in data that you think is reflective of a dog's capability of winning a race. So whether you want to do it just purely for that particular dog, or whether you want to do it in relation to the other dogs, there's lots of different schools of thought, but this one in particular does something really simple. So it's got 5 different features in here. The first one is total prize money that this particular dog has won over the last 365 days. So again, like I said, it's a proxy for the quality of the dog. If it wins better graded races, it means it's typically a better dog than something that wins poorer grade races, or something that doesn't win at all. And hopefully that's a signal of the quality of dog in that race. Feature number 2 is the number of runs that it's had over the last 365 days. By itself, probably not very useful, but when you look at feature number 3, it's essentially a win percentage over the last 365 days. So if it's run 50 races in a year and it's won 30 of them, that's a really good dog. If it's won like 1 of them, maybe not. Simple stuff to put into perspective, right? And what you're trying to do here is just code these kind of logical assumptions into data features that you can then use to predict later. Feature number 4 and 5 here is trying to find out what the best runtime was for this particular dog in the last 365 days. But before we get to working with runtimes, I probably skipped over this bit where we're doing some sort of normalization for the dog's runtime. Because each track has a different distance and each track is different in itself, you need some sort of scaling to make sure that they're all on the same scale. So I think one of the simple things that this tutorial does is introduce a concept called Z-score, which is just trying to plot a distribution of all possible runtimes and finding out where this particular runtime sits within that. And I think that's my simplest explanation to that statistical concept, but read more about it. It's a nice way of scaling across things that aren't similar, right? So using Z-scores, feature number 4 and feature number 5 essentially talk about best runtime and median runtime. So you're trying to predict with feature number 4 what this dog is capable
Help me out, guys. Is this me or Kaushik who's dropped off?
Kaushik.
Okay, great. I assumed it was me. All right. Well, as Kaushik, hopefully he can come back online. Maybe Ben, you can hit him up and make sure he knows that he's frozen. Let me jump back into where he was, and I can keep going. So, oh, we got you back. Cool. You froze.
Oh, okay.
So you just finished talking about Z-scores. You're back.
Excellent.
You just finished talking about Z-scores. And you were talking about medium runtime over the last X period.
Oh, sorry about that. My internet is not great these last few days, but hopefully
I assumed it was me. So it's all good.
It's definitely me. Yeah, so I was just trying to say is there's plenty of different ways to go about this, and this is just a template. You can work with things like, you know, not just medians and best, but also different ranges of how you would interpret Z-scores. You could work in things like trainer accuracy or like how often a dog places, how often a dog wins and stuff like that. So there's plenty you can do, but the underlying concept is, are you trying to get something that could be potentially predictive in nature, and how you convert that into a metric of some sort.
What I would love to do is go back and talk to pre-Betfair Kaushik and see how much of this Greyhound knowledge you would. I think you would have had a funny opinion of yourself now. It's amusing.
Absolutely. I definitely hadn't watched a single Greyhound race before I started at Betfair, but I've watched more than what a normal person should.
I love it. Sorry, keep going. Z-scores.
Yeah. So once you run these 5 features, this is typically what your data should look like. So you've got some things here, like, you know, the number of times it's run in the last 365 days. This is obviously a maiden, and working with maidens can be tricky as well. So you have to figure out what an average maiden dog looks like, and then impute some of these missing values that don't exist when you do such simple feature aggregation. But you can see with some of these other dogs, right? It's run 4 times in the last year, but it hasn't won at all. And hopefully that's a reflection on how good or bad that dog is. So when you run this code, you should be able to get this level of data for all of the dogs that you've scraped from the API step previously. Yeah, cool. So once you've got all of this, the next step is to push it into a model. So again, for simplicity's sake, the model is a very, very simple logistic regression that's coded here, that comes from the scikit-learn package. There's obviously lots of different options available. You can go from simple logistic regression models, you can do complex neural networks and stuff like that, but it's essentially, there's no free lunch with any of these models. They've all got positives, they've all got negatives. You've got to figure out what matters to you and use that particular technique. Yeah, again, for demonstration purposes, this is just a simple logistic regression. And the features are defined here in terms of the ones that you want to use to predict. And you've got, here's the code for that. Yeah, so it's only training the model of races where a dog has a value for each feature. So skipping the maidens and stuff like that. It's not the smartest way to do it, but it does the job for going through this tutorial in terms of steps. And what you want to do is maybe handle any null values. So the simplest way of doing that is just dropping things that don't exist, but sometimes that's not an option. You need to figure out how to eliminate null values and create what you think is like a best guess for coding there. So once you've got that, what this tutorial is doing is splitting your data into a test and train set. So this is really important because you don't want your model to overfit on a particular data set. Edges in betting markets are hard enough to come by as it is. The last thing you want is you thinking you've got an edge, and then once you roll it out in the marketplace, suddenly numbers don't look so good. So you want to do as much as possible to ensure that your model is as general as possible and not specific to a particular data set. So one of the simplest ways to do this is just splitting your data set into a training and testing data set. So what you do with the training data set, which is about 80% of data, is make your machine learning model learn from that data set, and then you want to use the rest of the 20% data to validate whether your model is good or not. So there's, yeah, like I said, there's multiple ways to do it. There's things like cross-validation and multiple holdout sets and stuff like that. But for simplicity's sake, again, it's just an 80-20 test and train split here.
If anyone were particularly interested in other approaches that you might recommend, could they hit you up on Slack?
Yeah, absolutely.
I think for people in the, we know we have a spectrum of people in the community, and you're obviously at the top end of that modeling spectrum, but we do have other people with a decent skill set in that space, and if they wanted to reach out, this might be an interesting piece to pick up.
Yeah, and the Slack community is actually great at discussing this kind of stuff. So if anyone's got, you don't have to obviously share your edge, but if you've got like clear things that aren't sort of prescribed in academic literature that have proved useful for you, people would love to learn. So when we do that splitting of training and testing data, and you train your logistic regression model on the trained data, what this section talks about is the fact that each dog, your prediction is trying to predict, is trying to say whether that dog will win a race or not. So the data set that you have, that you fed into the model, has no underlying understanding of the fact that dog 1 is competing with dog 2, 3, 4, and 5 in a particular race. So that's why when you add up the probability of each dog winning, it's not guaranteed to add up to 1. Yeah. There are certain techniques that you can use, as it says here, conditional logistic regression, which let you specify a particular grouping mechanism. And once you do that, you can ensure that the probabilities sum up to 1. There's also alternate methods that people use by just restructuring the way you feed your machine learning algorithm data. So instead of trying to predict whether each dog wins or not independent of each other, you may want to do it at a race level. So you've got features for all of the different dogs, and then you're trying to predict which dog wins. There's, again, pluses and minuses to either approach. There's in dogs, it's a little bit easier because typically there's always like 8 runners in dogs field. But if you do apply that thinking to horse racing, it's a bit difficult, right? There's 4 horse races, there's 24 horse races. Like how do you structure your rows and columns in a manner where that's consistent? So that's the downside of the other approach, but it will give you probabilities that add up to 100%. So if that is not the case, as it is here, you can see that some of the probabilities are like 84%, some of them are 117%. So you want to make sure that adds up to 100%. So one of the simple ways in which that's being done here is just a scaling. So just making sure that things add up to 100% with a simple formula that says x by sum of x. So that way you're proportioning the difference that's not adding up to 1 to force it to 1. So this is very simplistic. This won't always work, but it does the job again. So some rudimentary checks here after applying that transformation, you can see that the probabilities do add up to 100%. And that's when you have a model that you've trained, and you've also ensured that the outputs of that particular model are mapped to probabilities, and probabilities on the scale where it maps to odds as well. The last bit here is just a very simple check, and it's really important to do these kind of simple checks because you can get lost in the weeds. The simple check that this tutorial does is it looks at the starting price that's available for every race, and there's a very simple staking strategy of, like, it's not even a staking strategy, just like a betting strategy of sorts, where it says if I use the top prediction of each model, or if I pick the favorite according to my model, and if I pick the favorite according to what the starting price is, which one's better, right? So clearly in this case, because it's a relatively simplistic model that doesn't have too much thought, you can see that it's reflected in that data. So the model predicts the winner in 33% of races if you just go by the top selection, but starting price actually does that 41% of the races. So
you're not beating BSP.
Yeah, you're not beating BSP or whatever the starting price is here. I don't even think this is BSP. This is probably like a blended corporate price.
Probably even worse.
Yeah.
I don't. These sense checks are really important, right, Kaushik? Like whatever sense checks you do, it's so easy to miss a step, to bias things. Like I can't name a data scientist I talk to who hasn't biased models at one point or other. I know my first Greyhound model, I managed to include the BSP of the race in question. Excellent. And I was in this amazing, like we've all been there. And like I know Ben, one of our guys in the team, he played with a model for the Euro as part of the datathon that's on at the moment, and he's like, I had this really good thing, and I was looking at the prices, and I was beating the odds in every single market, and he's like, oh, wait a minute. And the whole fact that his model was significantly better than the odds made him sort of go, wait a sec, there's probably something up here, and there was. So it's amazing how much that that visual check can let you know that actually you probably screwed something up.
Yeah, the checks are really important. So go work with the golden rule. Like if it looks too good to be true, it probably is. And secondly, like be skeptical of as many things as possible. So build in benchmarks. Benchmarks, I think, is the typical sort of machine learning terminology for this. So in like standard machine learning models where you're trying to predict whether, like, in like corporate scenarios, right? Like whether customer is likely to churn or not, or customer is likely to click on an ad or not. Your model is typically meant to be better than random guessing. So if you have an accuracy that's better than 50%, it's considered like a simple baseline for you to have a model better than guessing. So think of something similar like that. So you should be able to, if you're able to make money just picking the favorite in every race, which is probably not realistic, then you want your model to be better than that, right? And that's what this simple check is trying to do. So there's more sort of complex mechanisms, again, where you can be as battle ready as possible, but the key thing is to have those checks in place.
Probably the one other thing to flag there, and I know that this gets discussed on Slack quite a lot, but I don't think it's well enough known across the community, is that if you found a model that's returning a significant percentage return, and we won't get into how you define profit on turnover, but if that's a big number, it's probably wrong, because we've got to work with a lot of successful people over the years, and very consistently their returns, anyone who's automated, they will be small. We're talking 3 to 5% is really good. So if you've got something that's returning 15 or 20%, it's probably not going to fly. For whatever set of reasons, just again a finger in the air check, but it's worth sort of considering that most sustainable models have a small edge.
Absolutely. Cool. So that brings us to the end of the second section, which went quite fast through some complicated machine learning topics of building a model and putting benchmarks in. But there's plenty of information available on this in the World Wide Web, right? So have at it, but now you know how to apply that to the domain knowledge of Greyhound racing as well. So that's pretty cool. It's a superpower when you figure it out. Cool. So the next bit here is just how do you convert this stuff into betting, right? Automated betting. And actually, for a lot of people, if you end up with a model that produces outputs, that's fine. That's the end of the pipeline for a lot of people. Then they typically tend to take the outputs or the probabilities or the odds that a model generates, and they're able to apply some sort of simple staking strategy or betting strategy with it. The problem with that is, like, if you're intuitively really good at it, that's fine, but the human mind has limits to how that scales, right? So you want to be able to place a bet on as many races as possible to make sure that you don't get stuck by variance. And you also want to be able to do other better things with your life, like hanging out with your mates or playing with your kids and stuff like that, rather than sitting in front of Sky Racing watching Greyhound racing at 10 o'clock at night. And there's enough people who do that.
Not speaking from experience or anything.
So if you can automate that stuff, then you eliminate yourself from the risk of like emotional betting as well, right?
Yeah.
You stop chasing losses, you stop doing all of that stuff that a consistent strategy or consistent mechanism of betting allows you to do. So the next two bits are essentially going through that. So the third bit is retrieving lineups for today's race. So this is doing it from the FastTrack API again. So like we spoke about earlier, there is a mechanism where you can get the fields for today's races as well. And that's available through these two functions. It's not very intuitively named. It's called get basic format and get full format, but that's primarily down to the FastTrack API's documentation and the language around it. But the key thing to notice here, get basic format gives you the field for today with very simple dog lineup and form information like box, best time, trainer, owner, stuff like that. The full plus format or the get full format will give you additional information with quite detailed information about previous starts and previous races and stuff like that. So again, the basic stuff should be enough here, but feel free to explore the full form and see if that works for you. So in this tutorial, again, what this is doing is running this get basic format for this particular date, which is when this tutorial was written. And just exploring that data, you can see that it says for race number 1, this is the name of the race, and this is where it's on the 16th. It's got this prize money. It's at Albion Park, and so on and so forth. So it's got that in the races today data frame, and in the dogs today data frame, it'll have more about the field of dogs that are running in there. What this is doing after that is fetching the same information from the Betfair API, because again, you want to be able to automate your betting, right? So for this, again, you will need a Betfair API key. And if you don't have that yet, again, reach out to KG and her team. We have a pretty streamlined process of providing this. And even if you see online that it costs you a little bit of money, this is on us. Cool. So the way to access the Betfair API through any tool, like most programming languages have a wrapper written for them that's publicly available. This one, because it's written in Python, is using probably the most popular one at the moment, which is called Betfair Lightweight. Pretty cool package. It lets you not just transact with the API, but also lets you work with the Stream API and historic data and stuff like that, which is quite powerful. But again, for simplicity's sake, we'll just be working with a subset of capabilities within this particular package. So once you've got an app key, which KG will sort you out with, you use your username, password, and app key to be able to automatically trade. And the Betfair API, which is quite reasonably well documented, has a few endpoints that you can hit up, right? So the bit here in cell number 18 and 19 is essentially trying to get what events are available today. So there is a list market catalog API that gives you the list of races and certain details about the type of races. And there's also something called list market book, which I don't believe this tutorial uses, but it's useful to understand what the current makeup of that market is. So if you want to build in any logic of, my model says price should be this, but if the market's price is so and so, then do something else. If it's not, have another piece of logic in there. So if you want to do that, use the list market book API, but list market catalog should be enough to get you started and enough for the purposes, the scope of this tutorial.
And there are lots of other tutorials on the betting part, which is why it's completely glossed over here. The only reason that we've sort of encouraged the betting part to be in here is for that linking of data, so that, we could have done this just on the FastTrack API, right? But then, we're then leaving people out in the cold to do the marrying up of the two data sets and all that stuff. So that's why we wanted the end-to-end. But this really, you would never bet a model. I hope you would never bet a model that looks this simplistic in terms of your implementation. So, but there are lots of other tutorials and resources on that.
Yeah. So the rest of this section, I think we're sort of running out of time, so I'll gloss over this fairly quickly. So the rest of this section is essentially getting data from FastTrack, getting data from the Betfair API, and also merging these two together. So for the purposes of these two data sets, you should be able to link it based on things like runner name, event venue, and race number. You might have to do a little bit of massaging with the data, like, converting all of them to the same case so that you miss out on different type of casing. Some of them might capitalize like the first letter, some of them might capitalize the whole thing. So you want to make sure that that stuff is consistent. Some of the other things that typically you have to watch out for when you merge data sets is things like apostrophes, right? I think, if I'm not mistaken,
we don't
do apostrophes, but FastTrack's API will have I apostrophe M for I'm on fire. So you want to make sure that all of that is handled for. And I think that at some point this also tries to map the event venues that we have at Betfair and how that is coded on the FastTrack API as well.
And I think that's part of that mapping doc.
That's right. Yeah.
Which is really useful.
Yeah, it's really useful because this stuff, it is not meant to change typically, and if it does, it changes quite slowly. So you can always sort of go back and adapt to it. But the fact that it gives you a head start, that's really good. So once you are able to link these two together, you now have a data frame that has the output of your model, and you also have all the details about the market ID and the selection ID and stuff like that that allows you to then transact and place bets. So I'll go through section 4 really, really quickly because we've got plenty of other tutorials, as KG said. Yep. So what this does is just has some logic on the probability output that your model has, which is here. So let's say for this particular dog, Little Miss Wayne, it's 17.79. Then there's some logic here, which should get you thinking about staking strategies and betting strategies and stuff like that, which says the minimum odds that I want to get on should have at least a 10% overlay on my model prices. So this is, again, you're trying to build in buffers and margins to make sure that your model is protected and your edge scales, so that when you're winning and when you're meant to win, you win more than you should, and when you lose, you lose less often than you would like. So even though this says your model says this dog should be rated 265, you only want to get on if it's 292. So there's risks, obviously, in the sense that you may not get on, but I think overall building this kind of buffer is really good for the general health of your model. The other thing that it says here at some point, and I can't really find out, but it does say in this tutorial, is making sure that when you're transacting with the Betfair API, the prices that you request for, or the prices that you want to get on for, should be a valid Betfair tick or Betfair increment. So obviously you can't ask for 19.57 because we typically don't have that. So there it is. Yeah. So if you click on this link, you should be able to find out what a valid Betfair price is. So here 19.578730 is not, but 19 is, or 20 is, or 1950 is as well. So you want to make sure that that's valid. Otherwise you get like API errors, which can be a bit discouraging.
And we've also, if you're not using this to do your betting, there are a couple of different, I guess, functions that we've shared on the Betfair down under GitHub in a couple of different languages for what those fields are. Obviously, there's one here. It's not that complicated, but there are more or less efficient ways of catching for it.
Yep. So once you've got all of that sorted out, you've built in an outlay, you've built in mechanism to make sure that the odds that you're requesting is a valid Betfair price. There's this function called place back bet, which just again uses the place instructions that's available for you from the Betfair lightweight package. You have to specify a few things like limit, which essentially means that it's a normal exchange bet, which is set to lapse when the market is meant to go in play. Obviously, Greyhound markets don't go in play, so you can either choose for it to be defaulted to the BSP, or you can just let it lapse. There's a bunch of documentation that you can look at to find out what are the different options that's available for you. But this is just placing a simple exchange execution bet on the backside at a minimum odds of the 10% overlay. So once you do that, you should get messages like this that says the placement on this particular runner was successful.
And a flat stake is the other bit, Kaushik. Yeah.
Flat stake of $5.
Really simple.
We can get into a whole depth of conversation about what good staking is and what are the different approaches that are available for it. But again, for simplicity's sake, it's just a $5 bet on each of them. There is a minimum amount that you must place on each bet, which I think KG will work with you if you want to sort of test out. And if you're not happy with $5 stakes to begin with, we can sort of help you out with that as well. Yeah, I think that's probably it. If your bet placement errors out, you should get relatively meaningful messages, which you can then check back with the API documentation. And yeah, if you can do this, follow this from start to finish, you will be betting with the shit model. But if you explore each of these individual sections and get better at pulling the data, get better at building a model, get better at placing strategic bets, then who knows, you could be successful.
And there are also the things that, like I said, not only there are other models, like if you look at the menu on the left, there are, you know, each of those subsections is different models modeling tutorials that we've shared, as well as a whole heap of other sort of betting and API ones. But also they're the things that the community can help with more. You know, there are all these conversations happen on Slack every day about what's the best staking approach, what's the best backtesting approach, you know, what should you use for X, Y, Z. There are lots of different places to source that information. But that end-to-end of how you actually follow the process, you know, we thought was a good fundamental to let you get from one end to the other. So hopefully that's what this provides, as well as just the access to the data and the wrapper to make it a little bit easier. And also for those who are more visual learners, you know, a way of going through it without just having to read through it. So hopefully that's been valuable. There is a question here around when we were talking about the profit of the model. So that was looking at the win strike rate and using that as the
that's right, yeah,
the metric. Question here is talking about, well, you know, are there other ways? There are other ways, but what other ways would you potentially take to looking at that weren't strike rate, given that obviously, you know, if it was picking good roughies, you don't need roughies to come in 33% of the time.
Yeah.
What other metrics? So my favorite is to look at your rated price against SP, because SP is considered generally the true mechanism, you know, the true price of a runner. And that lets you sort of at least get a ballpark of whether you're on the right side or not. But what about you? What would you take as your?
Yeah. So I think SP is really good because it's a collective opinion of the whole marketplace, right? At least in like super liquid markets. And if you can beat that, it's a close-ish representation to what true probability should be in a liquid market. So all of those caveats aside, I think it's a good comparison. What you can do is also get to a certain level of depth in the whole sort of machine learning terminology. So typically, a lot of models are optimized on a metric like log loss, which works well here for the fact that odds and probability have an inverse relationship. So if you can beat the log loss of something that you think is a good mark, like for instance, let's say the Betfair starting price. So if you can beat that, then chances are that you have a good model. If you're around that, and if you can't beat it but you're around it, it means that you need to get thinking on like a subset of your betting that will get you across the line, right? So whether it's pick roughies only or pick favorites only, or maybe apply like different outlays for different types of runners,
or so maybe, state, or whatever other filter.
Yeah.
I mean, the other beautiful thing about SP, right, is that especially when you're starting betting a model, it's really easy to implement SP. Like I would be using a limit SP, bit of logic here as a first go, because you know whether you're likely to get on or not. And therefore reality is more likely to mimic, you know, history, which can be one of the biggest problems. And
the other thing you can do is again, like work with KG, because she does this to all of our customers in providing samples of what the exchange looks like at different points of time. So maybe what you figure out is that your strategy is profitable at, say, the 5-minute mark, but not the 2-minute mark. And we have data products that let you assess how your model would perform against different, you know, views of the exchange markets. So if you typically do well at a particular time point, then maybe your success criteria is better off at that time point. So there's plenty of different mechanisms to use, but the key thing is to create some sort of a benchmark and make sure you beat that on a general basis.
And consistent. So another question, and this one I'm pretty sure comes from a former Betfair data scientist. Do you have any nifty feature ideas? If anyone wanted to look at something a little outside of the box in terms of feature creation, any guide you could give to someone to start going down some rabbit hole other than the ones that are in here?
Look, I off the top of my head, like I can't think of anything that's like particularly nifty, but I think it's just try and map out an understanding of what you think is predictive, right? And you want to build that into features. So it's Z-score is obviously like one way of standardizing that, but I'm sure there's like other mathematical ways of equating tracks across distances and different types of tracks and stuff like that. So a bit of a cop out. I can't really think of something like that, but yeah, I'd say like think of an approach where you think you can map out what might be predictive, and then you can find out ways of building that into features. So
excellent. If there aren't any other questions to come through, obviously I'm trying to keep this with our hour. Hit me or Kaushik up on Slack, you know where we are, and always open to conversations with anyone who wants to chat. I guess in summary, a couple of things I wanted to just review. Like, we've sent the link to the tutorial in the repo. Have a look. If you come across any issues or any feedback, please hit us up. You know where we are. We always love to hear that. Equally, if you are interested in access to the feed, please shoot us an email, data@betfair.com.au, and we'll have a conversation and see what we can do. Because keen to support for anyone who's keen. There were two other things that I wanted to highlight before we finish. We have some pretty exciting roles in market at the moment that we're hiring for. One of them, devastatingly, is Kaushik's, which makes me very, very sad, as not only a very dear colleague, but also a very dear friend. So very sad that we're losing Kaushik. We're also losing Ash. Ash is going to another internal team, which is very sad too. So losing two of my closest companions. So please, guys, help me replace them. Obviously, I'm not a hiring manager for Kaushik's role, but I have Ash's role. So if you or anyone in the community that you know is looking for a new opportunity, and you think might be a good fit for the role and the culture that we've got here, please reach out. We've got the LinkedIn links there. It's interesting how many of our successful hires have come from within the community. And we love that. So, you're some of our best resources, so we're going to use you for it. So if you've got any recommendations, please shoot them through, and let me know. I may be able to help you out with a little thank you for the effort, because I do appreciate it. The one final thing I will say is, like I said, reach out for access if you're keen, and or if you've got any other questions. For anyone who's new to the FastTrack API, we might be able to provide a little bit of help in the first little while, from a commission perspective too. So let us know, and we'll see what we can do in that space. Otherwise, if you don't have any other questions, guys, thank you very much, Kaushik. I really appreciate it, and you will be very sorely missed.
Thanks for having me. I miss everybody at Betfair as well.
Yeah, very much. And otherwise, see you guys on Slack, and next time. Have a good one. Bye.
Bye, guys.